Okay, well, we're to page 3 of the notes, and even though the section's called Graphing Quadratic Equations, we've spent the first 2 full pages not really drawing an official graph, just talking about the pieces that we're going to put together to make the final picture here. And as I was creating these notes and then going back over them to prepare the other night, what I was realizing was I'm going to need some more room here, and I wasn't able to recreate these, redo the notes in time. So what I'm going to do here is I'm just going to flip-flop these examples. So bear with me, if you will, please. We're going to make this first example from page 639, same page, but we're going to make this one number 32. And over here, we're going to make this one number 28. And we'll do the what's different question over here. I'll even try to make it official. I'll do it in red here. What's different? Okay, thanks you guys for putting up with me on that. And that means I'm going to rewrite the equations as well. So instead of x squared minus 4 here, I'm going to have y equals x squared plus 4x minus 5. I'm just flip-flopping these two. And this one over here I want to be y equals x squared minus 4. Okay, so I'm actually going to start over here on the right, looking at this one. And we'll go ahead here. So the instructions say to graph the parabola whose equation is given. So our technique that we have right now is we're going to piece together some information, starting with, does it go up or down? Then we're going to look at where the X-intercepts are, where the Y-intercept is, and finally the vertex. So let's go ahead and start piecing those things together here. Our A value is going to be what tells us if it goes up or down. So our A value is 1, our B value is positive 4, C value is negative 5. Our A value is positive, so we know this parabola is going to have an upwards shape. Okay, so that's what we can expect. The next thing we're going to look at is the X-intercepts. So I'm going to use some space down here. In fact, let's see. Let me make sure I'm on screen here. Oh, I'm not. Okay. So I guess I'll work it. Over here. We'll draw the curtain and we'll use this space here. So I'm going to go for some X-intercepts now. We know it's going to go up. So that's the first thing we did. Second thing we're going to do here is the X-intercepts. That's where we let y equals 0. 0 equals x squared plus 4x minus 5. And we solve for that. Now if you go back in your notes, I believe this was one of the problems we did. Is it the one? I can't remember if I picked new ones or not. Nope, I picked new ones. Would have made it nice though. Okay. Well, no harm, no foul. Here we go. Okay, so I'm going to go ahead and factor this. This is factorable here. And I can say that I've got an x and an x. And if I do a plus 5 and a minus 1, that will give me my minus 5. Plus 5 and minus 1 will give me my positive 4. When I add them together, when I multiply, I get the negative 5. And so then I can factor, or I use the zero product principle and say, well, either x plus 5 equals 0 or x minus 1. In this case, we can expect a couple answers because this is telling us where it crosses the y-axis. And it's going to probably cross twice. Most parabolas cross twice unless the vertex lands right on it. Okay, so we solve for x here. I get x is equal to negative 5 by subtracting 5 from both sides. Over here, I add 1 to both sides. I get x equals 1. So my two x-intercepts are the point negative 5, 0 and the point 1, 0. I can go ahead and add that to the graph. So 1, 2, 3, 4, 5 to the left. Here's our x-intercept, negative 5, 0, and then positive 1, 0. There's our other x-intercept. So we know that much, and we know that it's going to be facing up. So the third thing we're going to do now is come up with the y-intercept. Do exactly the opposite. Instead of letting y equal 0, we're going to let x equal 0. And when you let x equal 0, the x squared piece falls out, the x piece falls out, you're just left with the c value. So when you do that, you get the point 0 c. In this case, you get the point 0 negative 5. So we know it crosses at 0, negative 5. And so this is going to be a chance for me to extend this graph. See if I can be as accurate as possible. Is that going to give me enough? Let's go just a little bit more here. And I'll try to keep the spacing the same here. Okay, so we know now that the y-intercept is going to be at 0, negative 5. So 0, negative 1, negative 2, negative 3, negative 4, negative 5. So there is our y-intercept at 0, negative 5. Okay. Next, we're going to see if we can find the vertex. So the last step is to find the vertex, and then by symmetry, we can piece the rest of this together. Imagine that, you know, if it crosses here, it's going to kind of come together at some point. I'm guessing the vertex maybe right about here. Let's find out what happens. So the vertex, we get our x-coordinate first by taking negative b over 2a. So we're going to take our a, b, and c values into play again. So negative b over 2 times a. In this case, our a is 1, our b is 4, so it's negative 4 over 2 times 1. That's negative 4 divided by 2. That's a negative 2. So far, our x-coordinate is negative 2, and then we've got to figure out how far down that is. So our vertex is negative 2 something. Okay, well, how do we get the other something? So the x equals negative 2, y equals, let's take our original formula here of x squared plus 4x minus 5. Oh, I just realized I'm probably off camera. I'm just brilliant at that. Sorry about that. Okay, so let's recap here. Vertex, x squared, negative b over 2a, and then negative b over 2a, and then I'm going to plug in that negative 2. Negative 4 over 2 times 1 gives you negative 2. I'm going to plug that negative 2 in now to get the y coordinate of the vertex. So I'm going to leave some space for my x. I'll go ahead and plug that back in. And let's do the math here. Negative 2 squared is positive 4. 4 times negative 2 is negative 8. Then we still have the minus 5. 4 minus 8 is negative 4. Minus 5, negative 9. So there is our y coordinate. So I'm at negative 2, negative 1, 2, 3, 4, 5, 6, 7, 8. Ooh, my little visual estimate was right on there. So there's my vertex. Now, by virtue of symmetry, I'm going to have a matching dot over here. If you can imagine, there's kind of a line of symmetry down the middle of the parabola, because we know it's going to look something like this. We know it's symmetrical, because that's what parabolas do. So it looks like I go over 2 and up 1, 2, 3, 4. So I'm symmetrical. I go to the left 2 and up 1, 2, 3, 4. And this gives me a fairly decent view here of what this parabola looks like. And we didn't have to create a table of points and do a bunch of plugging in. We got 4 pieces of information, used symmetry to kind of finish off the picture, and there's our graph. I'm going to go ahead and switch up the video here, and then we'll come back and do that number 32 on the left side of the page.